Hey, how's it going? I'm back here with some more great information about acids and bases. The last time I guess it's I talking now, it's not really we. We're talking just general principles of acids and bases. And I wanted to go over some calculations today and maybe hopefully get into some weak acids and bases. First, review pH. Is equal to the negative logarithm of the concentration of H+. It is related to OH. Remember, is that Kw, that 10 to the minus 14th equals the concentration of H plus times the concentration of OH minus. And if we have OH minus, the hydroxide concentration, we can also determine that H plus concentration. So if we have either quantity, we can figure out the other one. Secondly, I want to point out I found this nice Microsoft whiteboard. I was using some other program. You can see it's nice. And, it's a lot cleaner. It actually looks like how I write on the whiteboard, which isn't great. But I mean, come on, it came with this nice, handy-dandy Galaxy-colored pen. I mean, like, you can't beat it. This is awesome. Anyway, so if I want to figure out the pH of a strong acid, it's actually not too hard if you have the concentration. All right, so the first thing I want to do is if I have a 0.5 molar solution of hydrochloric acid, what is the pH? Remember, 100% ionization with that hydrochloric acid. So if I have 0.5 molarity hydrochloric acid, I will end up with the same amount. This is a 1-to-1 ratio. I'll end up with 0.5 molar H plus, and I'll end up with 0.5 molar Cl minus. So now, to get my pH, all I've got to do is take this concentration and take the negative log of it. So it's the negative log of 0.5 molarity. If you have the handy TI of 30XA, you type in 0.5 and hit log. It's going to spit out a number of, I think it's like minus 0.3. You just negate it. So your pH actually will be 0.3. Pretty low on the scale. Very acidic, as you would expect for a strong acid. All right, let's take a look at what we do for a strong base. Oh, how'd the screen change like that? Oh, whoa, it's like magic all of a sudden. All right, let's take a look at the strong base. Same situation, strong base is 100% ionization. All this sodium hydroxide is going to break apart in these two ions. What happens if I have a 0.5 molar solution of sodium hydroxide? Same situation, 0.5 molar. Right, and this is going to break apart, and when I do that, I'm going to end up with 0.5 molar sodium hydroxide. I'm going to end up with 0.5 molar, sodium. Why is it doing that? 0.5 molar hydroxide. Come on there. There we go. All right, now what will happen if I take the negative log of 0.5, right? That's giving me the POH, right, which is going to be 0.3, just like I had for the strong acid. So what do you think the relationship is between POH and pH? Well, it's going to end up being pH plus POH is going to have to equal 14. So my pH is going to be 14 minus 0.3. So my pH is going to be 13.7, which again you would expect for a strong base. But for bases, you're going to have to watch out for that because you're going to end up with hydroxide. And you're like, well, how do I get it into the H plus? And maybe you'll forget for a moment, but hopefully you remember, hey, if I take that negative log and make that mathematical symbol P, and I end up with POH. And there's your relationship, pH plus POH equals 14, and you can derive that using this stuff over here, right? If you take the P of both and the negative logs and how you do logs and multiply and all that nonsense. So I'll leave you with that. There's one more little complication I want to get to here, so give me a second. All right, so one other little bit of complication here is what if I have an alkaline earth metal? All right, they are 2+ cations, and that'll end up giving me 2 hydroxides as a product. So I don't have that 1-to-1 ratio anymore. So what will happen is I end up with 0.25 molar calcium. It doesn't really matter. But because, why does that keep sticking up? Get out of here. Because I have 2 of those, that means I've got to, for every 1 calcium hydroxide, I've got to multiply this by 2. All right, so I end up with a 0.5 molar concentration of my hydroxide. And I'm going to do the same steps. That POH, then if I take the negative log, is going to be 0.3, which means my pH is going to be 13.7. All right, so hopefully strong acids and bases make sense. You're just looking at how much my starting material. If you're given grams and a volume, you can easily convert that to a molarity. You can figure out how much you have as a reactant, and then from that take the negative logarithm of the concentration of whatever species you have in there, whether it be H plus or OH minus. Please, again, if you don't understand something, email me or contact me and I'll help you out. Now I want to transition into more of the weak acids and bases, which are more complicated. This is straightforward. The weak acids and weak bases take a little bit of work. So let me get the board set and I'll start it up again. Okay, so we're going to start with hydrocyanic acid, and it's weak. And if we make this an aqueous solution, it's weak, so that means it does not dissociate 100%, and we end up with these equilibrium. And it's going to dissociate into H+, which will be our acid part, remember, and our Cn minus, the anion part. Since it's not 100%, and weak acids and bases exist as an equilibrium, we can then write this as an equilibrium expression. So we have our K. Remember, it's products, concentration of products over the concentration of the reactants. So we have H plus times the concentration of Cn minus all over the concentration of my original acid. And this K is not Kc, it's not Kp. This is an acid, so it's Ka. And guess what it'll be for K for the K for bases? I don't hear you. Nope. It is going to be Kb. I thought you guys were better than that. And with the Ka, this has a Ka of somewhere around 10 to the minus 10th. I don't have it memorized. But the K, again, will allow you to get a handle on how strong is that acid. Strong acids, 100% dissociation, are going to have this exponent be much smaller. And the weaker the acid, the smaller this number is. So if you have 10 to the minus 30, it's super weak. And going this way, if you have 10 to the positive 30th, that's crazy. But if you did, that would be a very strong acid. And you have these things, which we're not going to talk about, but they're super acids that are negative pHs. But the principles for all these are the same. Whether it is hydrocyanic acid or acetic acid, you're going to have one H somewhere on it that's going to dissociate, and the rest of it will be the anion and it'll be negative. Bases work the same way. So if I have Na ammonia here, I have NH3, and that's added to 1. I'm not putting in the aqueous and whatnot. I guess I will. What the heck? There we go. And what's it going to form? It's basic, so it should produce, I hope you said it, OH minus. All right, where's that OH minus going to come from? It's going to come from the water. All right, so we have OH, remember the structure of water. So one of these guys is going to come off. And that's going to go to the NH3, and now I'm going to have NH4 plus. So some bases, it looks like it could be an acid because of that H there. But there are certain substances that are basic, and what they're really going to do is they're going to extract the H from water. Just remember that water is partially ionized anyway, so there's H plus is floating around. And it can do this. So if you remember the Lewis structure, we got the NH3. Sorry, I'm writing really bad now. But it's got that lone pair of electrons there. And that is going to attract to the, that's smiley face. That's going to attract to the hydrogen. I'm running out of time here. I could keep going on about how we can do calculations, but I think the calculations for weak acids and bases is going to have to be in another video. So you got lucky today. And I hope you enjoyed the Galaxy pen and the whiteboard. I did. I need 1,000 subscribers to monetize my channel. So if you've got 1,000 friends, I've got one. I need 999 more friends to get myself to monetize these videos. Do it for your teacher. Anyway, that's it. subscribe, like, and have a great day.